is going to be recorded.
All
With
right.
that, I'm going to get started. Everybody, welcome to Asset Management 101. This is being brought to you by the Colorado Stormwater Council and the Municipal Operations Committee. I am proud to introduce Chris Olson with Wright Water Engineers, and I just want to thank Chris for volunteering to do this presentation. And without further ado, Chris.
All righty. Thank you, Jeremiah, for inviting me, and Jessica for marketing this and sending out emails and putting together flyers and everything. Really appreciate that. As you know, we're scheduled to go until about 1 o'clock here. My plan is to wrap up a few minutes before that and allow some time for questions. In the meantime, if you do have some questions that come up, feel free to post those in the chat, or you can just chime in afterwards. That's just fine. And if we do go a little bit over 1 o'clock, that's fine too. I'm happy to stay on and answer as many questions as we need. So again, I'm Chris Olson with Wright Water Engineers. And so we first gave this presentation a couple of years ago, and Jeremiah asked if we could do it again. So really this is you know, a 101 type of presentation, just to kind of give you a big overview of sort of the steps that are involved with asset management. And you know, we'll go from there. So let's see here. I guess there we go. Okay. So the agenda here today, we'll just kind of give a quick overview of what asset management is. And then we're going to kind of go through the various steps involved, starting with an inventory of those assets, assessing the condition of them, and then ultimately moving into operation and maintenance planning and tracking. And then using all that information ultimately to you know, plan your financial expenditures and prioritize them. And we have some, you know, sort of standard methods that can be used to do that. And then obviously we'll have some time for Q&A at the end. So, you know, starting off, really, what is asset management? And you know, if you Google or read some different textbooks, you're going to get, you know, multiple different definitions. This is one that I kind of, you know, pieced together, and I think it makes sense to me, which is really, you know, it's a long-term strategy and approach to minimize life cycle costs of owning and operating assets while maintaining reliable levels of service. And, you know, you kind of keep that in the back of your mind as we move through, and you'll see that, you know, all these different steps that we'll kind of talk through really, you know, get to what I feel, you know, meets that definition. So, you know, the benefits of setting up an asset management program, ultimately, we want to reduce life cycle costs. At the same time, we want to provide, you know, maintain our level of service, and ultimately improve the level of service in doing so. One of the things, as you'll see as we kind of work through the prioritization framework, is that it really allows you to be transparent with how you're spending your money. Why did we decide to do this project over this project? It's quantifiable. You can validate the entire procedure for making those decisions on how you're going to spend the limited funds that you do have. And then at the same time, it does allow for, you know, more predictable costs, and ultimately, you know, the rates that you end up charging your customers. And so, you know, what I consider high performing asset management programs are going to include number one, an asset inventory and robust condition assessment, operation maintenance planning and tracking, and then of course, long-term financial planning. So we're going to go through each of these one by one. So obviously you have to start off by knowing what you have for assets. We're talking stormwater here. Really the approaches that we're going to go through are valid for, any type of infrastructure. But stormwater wise, we're talking about our pipes, manholes, outfalls, open channels, BMPs or stormwater control measures, etc. And, understanding what are the critical attributes to these assets. What are the things that need to be maintained? What are the things that have costs associated with them? You'll see, we'll talk about modeling a little bit. And then of course, where are they located? So, starting off, I think everyone's familiar with GIS and Esri. This is really the tool to use to track your assets. And each of these assets are going to have, some attributes associated with them or a schema. Obviously, this helps you, clearly identify the location of the assets, and we'll talk a little bit about, how precise do we actually need to be with, and some of the tools that we can use for identifying that, the locations and ultimately field, data collection. We have to go out and we have to inventory these assets, and we want to collect the attributes that we need to put into this database. So, it really starts off as you begin this process, and I'm sure some of you have, at least some of your assets already in GIS, and this is really a very, very important step to think through at the beginning of the process, which is, what are all the attributes that I need to collect and identify for each of the assets? And you really want to consider how those attributes are going to be used. So, for cost estimating, we may need to know the size, obviously, the length, the material, the type. We'll want to know what the condition is once we go out and actually do the inspections or condition assessments. So we might want to, put in attributes such as the condition score, which we'll talk about, installation date, etc. For maintenance, we'll want to track that. So maybe the last time it was repaired. Hydraulic modeling, specifically, for stormwater, but also sanitary sewer and water distribution networks. H&H modeling is very important. And so again, you want to think about what are the attributes that I need in order to build a stormwater model and run it. So again, talking about material, size, depth to inverts, depth to rim, things like that. Permit tracking and regulatory compliance. So again, when was the last time it was maybe inspected? Who owns it? Are there dry weather flows that were identified during the inspection and things like that? So there's multiple attributes, and Esri kind of has some built-in schema for different types of assets, for pipes, for example. But ultimately, each organization really needs to sit down and figure out what attributes they're going to want to collect and keep in their geodatabase. And every organization is a little bit different. And so really, this is a very important process up front, is to sit down and think about all this, because you'll see next, you're going to go out in the field, you're going to collect all this information, which is very time consuming. And if you ultimately come back down the road and say, wow, we really should have collected this information as well, you have to go out and redo that. So again, just want to emphasize that, you know, this effort should not be minimized, and really take the time to think about it before you get going. In terms of going out and, you know, locating the assets, you know, you have a couple of different sort of levels of accuracy. What I would call, you know, survey grade accuracy, which is, you know, centimeters. You might want that for your inlets and your manholes and things like that. And that of course has, you know, some additional costs involved there. But you can also, in some cases, just kind of go out with an iPad or an iPhone, you know, what I call handheld grade accuracy of, you know, generally 10 to 20 feet. And that might be fine for maybe your large detention ponds, for example, and things like that. So again, think about that up front, and you know, the tools that you could use in order to go out and georeference your assets. Once it comes down to going out and actually collecting all this information, you know, again, ArcGIS or Esri has a couple of field apps that are available, Collector and Survey 123, for example. I think Collector has been, it's not being retired, but I think it's being replaced by, I believe it's called Field Maps, maybe. But the point is, you can, you know, set this up again on an iPad, on an iPad or an iPhone, and go out and fill in all these attributes right there out in the field. So you'll set up these custom forms that say for each manhole, you know, these are the attributes I want to collect and fill in. Take photographs of all the assets, and then ultimately all of that can be automatically imported into your geodatabase. So these are really helpful tools. We use them quite a bit whenever we're out in the field. And again, it takes some time to sort of, you know, think through what those forms are going to look like and set them up. But then they can be used over and over again for each type of asset. So once you've gone out and really identified where all your assets are, you know, at the same time, depending on what you're inspecting, you also want to do what we call a condition assessment. So, you know, determine the existing condition and the level of service of those assets. And so that can be field inspections, obviously, as a starting point. For pipes and manholes, there's a couple of different standards that we can use. Pipes, of course, need to be inspected with you know, CCTV. And then other assets, again, just going out in the field and inspecting them without really any special tools that are necessary. Another aspect of condition assessment, again, is getting into the modeling portion of things. So, you know, what is the level of service? Where do you have constraints in your system? And really, that's kind of getting into stormwater master planning at that point. The other thing you'll want to do is establish what we're going to call rating scales. So as you go out and inspect, you'll want to you know, give a rating, give a score to each of the elements that you're looking at, and you'll see ultimately how those scores are used in the prioritization of future projects. So pipe inspections, there is, again, these are obviously done using CCTV. And there is, you know, sort of a standard protocol that's out there. It's called the Pipeline Assessment Certification Program, or PACP. And this really establishes, again, kind of a standard so that when someone's reviewing these videos, they can assign scores and define what the different defects might be. So there's, different levels of root intrusion or different levels of cracks or cross connections and things like that. So it's really good to, talk with your contractors, ask them if they are PACP certified, if they understand these standards, and really then you're operating on the same playing field as other utilities and organizations that are inspecting their pipes using the same standards. At the same time, for manholes, for example, there's a similar protocol. This is the Manhole Assessment Certification Program, or MACP. Again, just a set of standards that can be followed so that you're rating, each of your assets, each of your manholes according to, a quantifiable scale. And there's really two different levels of MACP. There's a level 1, which is what we kind of call just like a from the surface inspection. Pop the manhole cover, look down, take some photos, just kind of do a general assessment. And then there's also a level 2, which is a little bit more detailed, where you might actually use some special cameras or some special equipment to identify specific defects and corrective measures. In stormwater, we're usually less concerned with things like I&I and things like that. So usually a level 1 is plenty adequate for most stormwater infrastructure. And then again, similar to the PACP, it has, these standards have certain codes that you can use to rate the manholes against each other. Of course, we have other assets in a stormwater system. We'll have inlets, we have outfalls, we have stormwater control measures, etc. There's really not standard assessment protocols for a lot of these other assets. And so this is where, you kind of sit down with, within your organization or a consultant and develop those forms and what criteria you actually want to use to do your assessments. So you can see here, this is just an inspection form for an EDB. You can come up with, I'm sure most of you guys, most of you already have inspection forms for stormwater control measures, but you might do the same for inlets or outfalls as well. Again, most of what we're, condition assessment so far is sort of out in the field and inspecting in person. But again, you don't want to disregard, modeling. And what modeling can do is really help you identify, is my infrastructure undersized? Or, can I convey the 10-year that I'm, 10-year storm that this was designed to, or is it undersized at this point? So that's another critical aspect that goes into assessing your conditions. And again, we're really starting to talk about stormwater master plans at that point. So a rating scale, again, is really designed to kind of normalize all of these conditions to a certain scale. Normalize being, how do we rank what's a good, what assets in good condition versus what asset is failing. And I really like to start simple and generally what you would do is apply a lower score, is that means a better condition. So you might start simple with just a 1, 2, or 3 rating level. You know, 1 would be good condition and you know, don't need to reinspect for another 10 years, versus a 3, which may be a poor condition and immediate repairs. You can also, you know, you can take this to various levels. Maybe a 1 to 5 scale where you differentiate a little bit more between different levels of good condition, fair condition, or poor condition. In some cases, you know, maybe go up to a 1 to 10 scale, but really at that point, it becomes difficult to kind of determine what's the difference between a 3 or a 4. So I really like to keep it, you know, a 1 to 3 or a 1 to 5 type of scale for everything. And so after you've gone through all of this, you've mapped all your assets, you've gone out, you've inspected them, you've perhaps done some modeling, you know, then you can start to assemble these tables where you have a rating score and you know, a reason why that rating score was applied. So at this point, we have really addressed, you know, what do we have and where is it and why have we rated it, given it the score that we've given it. And so now we're going to use this information to plan our maintenance or repair or replacement of these assets. So now we're really getting into, you know, when are we going to do something, who's going to do it, and how are we going to do it. This gets into the operation, maintenance, planning, and tracking. So I don't know if, I'm sure some of you are familiar with CMMS, computerized maintenance management systems. They are, there's a lot of them out there. And really what they are is a dynamic database to manage operation and maintenance tasks and data. And a lot of these platforms will directly integrate with your GIS. So, you know, what these CMMS programs do, or what they can do is, you know, import tasks, import ratings, and from those they can issue work orders. The crews that are out in the field can track, you know, how long they've spent working on this particular project or repair. You can track complaints that are coming in, issue inspections, track repairs, and then all of that, again, because it's generally integrated with GIS, is then you can update fields like when was the last time it was inspected, what kind of repair was done, and things like that. So again, planning for your GIS schema up front, really you need to think about what information you're going to be tracking in a CMMS type system. The idea here is, you know, not only assigning tasks to the maintenance crews that are out there, but really collecting the data then of when repairs are being done, when replacements being done, how much does it cost, and all of that is going to be building this database for your long-term, you know, financial planning. And again, there are dozens of these CMMS vendors that are out there. I've put a couple down here, not endorsing them by any means, but these are some of the more common ones you may have heard about or seen, or perhaps maybe even use. So over time, you know, what we really want to do is get away from a reactive maintenance type of a program. That's typically the most expensive. I think we all understand that, but it's usually much more much less expensive to be moving towards a proactive maintenance type of regime. We understand budgets are limited, and the sustainable long-term financial planning really involves, number one, a risk-based prioritization of all of your assets. And we're going to kind of walk through that a little bit and what that means. And then, of course, tracking your life cycle costs and estimating what those might be so that you can make decisions that are going to minimize those life cycle costs. So what do I mean when I talk about risk-based prioritization? Risk is defined as the likelihood of failure multiplied by the consequence of failure. So what we would typically do here is we can set up a matrix such as this, where we will quantify what is the likelihood of a certain asset failing, what is the probability of that asset failing, and then also what are the consequences if that asset ends up failing. And so, of course, you can see in the lower left, if you have a low likelihood of failure and a low consequence of failure, you're going to have a low risk, versus in the upper right, you have a high risk if either your likelihood of failure is high and or if your consequence of failure is high. And you'll notice, you'll notice that it's, there's also sort of in between. So there's a medium risk, and you may have an asset that has a very low likelihood of failing, but if the consequences of that failure is really high, then you may have a medium risk somewhere in between. So again, this matrix can be like a 3x3 as we're showing here. You can do a 5x5 matrix or something like that, but this is the general approach. And in terms of likelihood of failure, I mean, what do we base that on? Well, number one, our condition assessments and the data that we've collected as part of that. Other typical factors that can come into play is, of course, the age, the material or the type. Corrugated metal pipe, for example, has usually a higher likelihood of failure than, say, RCP. You can also, especially if you're talking about BMPs or stormwater control measures, it could be the location and the contributing area. Some areas we know are dirtier or have higher pollutant loadings than others, so that could be a factor. And then, of course, your repair or maintenance history, and so that's getting back into that CMMS. So over the years, if we've been populating that CMMS with how often do we need to go out and maintain this particular asset, over time, we can start to bring that data in to this risk-based, this framework. And then in terms of consequence of failure, again, there's multiple different factors that can come into play. The size, for example, may be one. It may be the location. If this pipe fails in this location, it could result in significant flooding or flooding of critical infrastructure, for example. And then, of course, the cost. If a particular asset fails and it's gonna cost a lot of money to replace, we'll want to incorporate that into the analysis. So we define all these factors, and again, so then combinations of these are called the risk framework. Here's just one example where we might use data that we've collected over time to define a likelihood of failure. And in this case, what we, in this example, what we're showing here is that we've collected a bunch of data of repairs of, let's say, a certain of pipes, and we can plot those based on the age of the pipe, for example, and how many times we've had to repair that. And then what we can do is divide that up into maybe three different boxes where we apply our rating score. So anything, any pipe that has, a certain age that falls within the green box, for example, might have a LOF score, likelihood of failure score, of 1, versus anything that falls in the red box over to the right, we might apply a score of 3 for the likelihood of failure. And so for each of these, then we will, assign a rating score for the likelihood of failure. This could be based on the condition assessment work that was done. We may also have a likelihood of failure for age, for example. And then what we can do is add those 2 numbers up to get a likelihood of failure total in this column. And then let's say our consequence of failure in this case was strictly based on the size of a pipe, for example. And so, pipe 1 may be a large, 48-inch, 60-inch pipe. So we're going to give it a higher consequence of failure score of a 5, for example, versus, pipe 5 in this case maybe is only an 18-inch or a 24-inch. So we're going to give that a rating score of 1. And then our risk score, as I said, going back to the definition, is likelihood of failure multiplied by consequence of failure. So this ultimately is our risk score calculated here. Pipe 6 obviously has the highest risk in this example, because we have some pretty high likelihood of failure scores, as well as a high consequence of failure score. So then at this point, we have risk scores for everything. And now really what we want to do is get into our life cycle cost analysis. And again, life cycle costs are the total cost of owning an asset over its lifetime. And so if we've implemented our CMMS and we've been tracking all of our maintenance costs and repairs and replacements and things like that, we have a database of what we think it costs for, to maintain maintain and own these assets. And this is where we can really start to use this information to figure out, is it cheaper to repair or replace an asset now, or leave it go until it's at the end of its life? And so I really like this figure that's shown here from the EPA, because it really does show, what the costs are over time. And, for the first, let's say 20, 30 years that we own an asset, the costs, the O&M costs are, maybe pretty consistent. But as we get further along, 20, 30, 40, 50 years down the road, those costs start to escalate and start to increase. And so we may look for, over time, we can start to predict where those increases are going to occur, and use that to figure out, do we want to keep maintaining this and knowing that those costs are going to increase, or do we want to repair it, or do we want to replace it? And again, this is this is the long-term goal here, and it takes years and years and years to really collect all this information on your particular system. But you can also begin to populate this based on estimates of just understanding, generally what it's going to take. So you'll, apply this analysis to each of the assets to ultimately minimize what your life cycle costs are going to be. So, ultimately we've kind of worked through the procedure of collecting information, doing a risk-based prioritization and life cycle cost. And that's gonna help us, inform what are we gonna do with this asset right now? Are we gonna maintain it? Are we gonna rehabilitate it? Are we gonna replace it? And you'll do this analysis now, and then maybe repeat it 5 years from now, or maybe 10 years from now. And all of these numbers are going to change. You'll need to go out and re-inspect or pull data from your CMMS. And so it's a continual process that gets repeated over and over and over again. But you have this framework all set up so that all you're doing is pulling in new information and updated information each time you go through the process. So some final thoughts. Again, asset management, it's an ongoing process. You don't do it just once. It really is. It's an entire program that you follow over time. It really is important to invest in the data and the information. So go out and collect all your asset inventories, do good condition assessments, invest in some sort of a CMMS where you can track all of that operation and maintenance data over time. It can seem very daunting, I think, at first, but really, start simple. You don't have to do every asset all at once. You don't have to do your entire city or organization all at once. Maybe start out with a little pilot area, do one section of the city at a time, collect all the information, kind of go through this process so you understand it and can refine it, and then add complexity or additional data as you need, down the road. And then, the other thing I would strongly suggest is to, talk to your peers and other departments. I feel like the potable water folks and the sanitary sewer folks probably have been doing this, a lot longer, and so there's usually good lessons to be learned from those that have been working with these type of frameworks in the past. So let's see, I'm at about 40 minutes or so, and I see that there's a couple of questions up there. I guess we can, let's see, I'll bring those up. That's just Jeremiah. All right. Let me open it up. Does anybody have any questions? I know, again, it's sort of a 101. Threw a lot at you. I certainly am happy to have one-on-one conversations with anybody. If you ever want to email me, that's up here too, or give me a call. What do we have here? So, how do we access the presentation and recording? I'm not sure, Jessica, how are you going to post this?
Yeah, so we will post it online on the Colorado Stormwater Council's website. And if you don't have access to that, I'll go ahead and I'll put my email in the chat and you can email me and I'll send you a link directly.
So I wanted to add a few things, Chris, if you don't mind.
Please, yeah.
First of all, great presentation again. And thank you for doing this for the Colorado Stormwater Council. NASCO, the folks that bring you PACP and MACP, in the last 10 years, they've really tried to bring stormwater into their fold, because really it was really based around, like Chris had mentioned, sanitary sewers and supply line pipes. And they've really tried to incorporate things like catch basins. And I think that's where the level of manhole servicing came from, is because we don't have to worry about, like Chris said, I&I in stormwater. And then for anybody that's out there shopping for those CMS softwares, the stuff Chris just presented to us is so invaluable. I mean, it's so important, because a lot of those programs, they come with basic assumptions. They come with like canned formulas for calculating those risks and those assessments. And it's important for whoever's, the end users to understand how they're calculating that. And Chris just showed you how they should be calculating it. And so I think that's really important. And I really appreciate Chris breaking that all down for us. And last, Chris has done this for a couple of municipalities, done this kind of integration. And Chris is a very humble man, but I'm going to give him a shameless plug and tell you all that Right Water Engineers does this, and Chris has done this for a couple of municipalities, getting this whole architecture set up. So I just wanted to make sure I threw those out there. Finally, I would just say, if you're interested in looking at what other municipalities have done here in Colorado, through the Colorado Stormwater Council, we have what we call our C6 system, which stands for Colorado Stormwater Infrastructure Catalog. And I just put that link in the chat. And that's where we all go to dump our stormwater data, so that we can communicate about whose pipes are whose, and where are pipes going, and whose infrastructure is going where. And that is all set up on the CSU ERAMS system. So if you have any questions about that, please feel free to give me an email or send me an email, and I can help you out, because you do need a CSC login to get to that.
Yeah, thank you, Jeremiah. Let's see. Everyone's quiet and eating their lunch today, so they don't have questions. Yeah, again, and just to kind of reiterate what Jeremiah was talking about with this, risk-based. I mean, I'm trying to, presented very simple examples here, but the idea is that, I kind of want you to understand what the process is, because you're right. Some of these, softwares that are out there, it's, it can be a black box, but garbage in is garbage out, obviously. So, each of these takes, it takes time to sit down and really think through them. There might be a few iterations along the way, but it shouldn't scare you. And, again, I really like the idea of, being able to point to these numbers and saying, hey, this is the reason why, it's quantifiable, it's defensible. This is the reason why we did this project versus this other project that we're going to put off for another 10 years. So I think it's really important from that perspective, and trying to explain to your council members or your constituents of why their project didn't get selected this year.
I'll ask a question, Chris, since you're on the slide.
Sure.
So the typical consequence of failure factors, when you'd mentioned cost, what are some of the costs that would actually be calculated or are appropriate to calculate for this general risk prioritization?
Well, I think it's, the cost being, if this thing, if something fails, how much, how much is it going to cost for a total replacement of it? And, versus, perhaps just rehabbing it, or, do we want to let this asset go until failure, or do we want to try to repair it, and extend the useful life? So, there's other factors involved with, just, or even things like pipes and how deep it is. And, so it really just kind of depends on how you're gonna work that into the overall analysis. But, I would think a replacement cost is a good way to start.
Okay. Would it be appropriate to include costs of like external damage beyond just the cost of the replacement? So if,
yeah. So that, again, that, so what are the consequences of failure? It might not be, the consequences is not necessarily just the infrastructure failing, but your level of service is decreased. You're going to cause flooding somewhere. Your water quality, you're not going to provide water quality benefits for a certain stormwater control measure, for example. Okay. So yeah, again, these are just sort of like typical, but you can certainly expand on these quite a bit.
Okay, thank you.
Yeah, I had a all right, share the slide with the diagram again. So yeah, I really like this one because it really was, I don't know if there was a question that somebody had for that. But again, it kind of gives you, this is really what the life cycle of something, the costs look like. At some point they're going to really start to escalate, and you might decide to renew it. That gives you, brings your operating costs back down slightly for a certain period of time, and then they're going to start increasing again, and there's this, these fine lines of, do you let it go out to 100% and then replace it, or do you perhaps decide to replace it at this point where those costs start to escalate?
Chris, if I could just add on to that real fast, something that I think gets overlooked a lot. Because like we're used to dealing with numbers and engineering and water quality facts, and but public trust, which is something that's really hard to quantify, but it's really easy to lose. And I think this is a tool that helps you garner and gain public trust. If you're catching these things before they become a problem, you start to build public trust in your organization.
Yeah, absolutely. Mm-hmm. All right. Well, yeah, again, this is going to be posted. My email is here. Just C. Olson at Wrightwater. Feel free to give me a shout if you have some other questions down the road. And I really appreciate you guys taking the time today to listen in. And we'll see if we have to get to a 201 at some point.
We'd love that, Chris. And thank you, everybody, for attending today. And like Jessica said, this will be available on the CSU website probably in the next couple weeks. So thank you for coming, and I hope everybody has a wonderful day.
Thanks, everyone.